Hello and welcome. In this video, we are going to solve problem number 21 of Leetcode. So in this problem, we are given two linked lists in sorted order. So you can see that we have two linked lists, list 1 and list 2, which is already in sorted order 1 to 4 and 1 3 4. And we have to merge these two sorted linked list, and we have to make a linked list which should also be sorted. So if you are merging these two, then you can see that resultant linked list is also sorted. Okay, so you can't merge it like 1 to 4 1 3 4. You can't append just 1 3 4 in last. So we have to make sure that while we are merging this, our resultant so linked list should also be sorted. So how you can do this, let's say. So there can be many ways to solve this problem. The naive approach, or you can brute force approach, is going to be we can use a data structure, and any data structure of your choice. Either it can be array, linked list, array list, or vector. And in this data structure, use a data structure and store all the values. And then after, and then sort the data structure in increasing order. Okay, and then what we have to do, we have to make a linked list out of this data, and then make linked list. So how much time does it gonna take? So in first step, where we are storing all the values in data structure, so it is going to take big O of n time, and then we have to sort all the values. So for that, it will be going to take around big O of n log n. Okay, and then we have to make linked list out of this data. So for that, it also going to take big O of n. So you can see that this is very much time consuming. Big O of n plus big O of n log n plus big O of n. Okay, so and the space complexity is also big O of n, as we are going to use a data structure for storing all the values. Okay, so this is the time complexity, and this is going to be our space complexity. Is there any way we can reduce this? Yes, there is a. So we don't have to store our values in a data structure, or that's why we are not going to take this big O of n time complexity, and we'll try to solve this problem in big O of n time. We don't have to take the remaining step. Okay, how you can do that, let's see. So for that, just remove this. As our data structure is already sorted, so we can take help of that, and we can use two pointer to solve this problem. We will be placing one pointer at first linked list, and second pointer at second linked list. And for that, we will be creating first a dummy linked list, and then we are going to append all the nodes. So first we will compare both the nodes, so which one will be lesser or equal. First we'll check that, and then append this. We can see that both are equal, so we can append any of these. So after that, it will be going to 1, and then I am moving this pointer one step forward. Okay, now we'll compare 1 and 2. So obviously 1 is lesser, 1 will be appended, and then moving this pointer one step forward. 2 and 3 is compared, 2 is lesser, and then move one step forward. Again 4 and 3 is compared, so we will be moving 3 one step forward. Now 4 and 4 are equal, we will be appending 4, and then moving one step further, it will going to reach null. And whenever we will be reaching null any of the linked list, we have to append all the remaining linked list of another linked list. Okay, then it is going to be something like this. So now we have to return a result. So as we have used is this dummy node, we can't return it from here, we have to return it from here. Okay, so for that we will be returning dummy dot next. Okay, so this is the approach that we have to follow. Okay, first we will be writing the pseudocode for same, and then we will be solving this problem. Okay, so let's write the pseudocode. We will be running, first we will be creating a dummy node. Okay, and create a dummy node, and we'll be running a while loop then until and unless any of like list 1 is not equal to null, and at the same time list 2 should also be not equal to null. Okay, and inside this we'll be checking if list 1 dot value is found to be lesser than or equal to list2 dot value. In this case, we will be appending this dummy. Okay, as we have to return result, we have to store the dummy node in some another node so that we can return the head of this dummy node. So for that, we will be using a temp node and we'll be storing dummy here. Okay, so we'll be doing all the work in this temp node and then we'll be returning dummy node next. Okay, so we have to do temp dot next equal to uh, list1, and then we have to move our list one step forward. Okay, in else pass we will be doing the same for list2, do the same for list2, and then as we are appending the value, then we have to move our temp one step also forward. So move temp one step forward. So for that we will be doing temp equal to temp dot next. Okay, and then what we have to do, we have to go out of this while loop and check whether if any of linked list is not equal to null, is not null, we will append that in our result, and then the last step, that is we have to return a result. Okay, so this is the pseudocode that we have written and we have to follow this and write the code for some. So let's go to our compiler and write the code. Create a linked list node that is going to be dummy new list node. Okay, so this is the dummy node, we can name is as our requirement, so this can also be named as result. Okay, so we have to store this result somewhere, so we can store it at temp, and then we will be doing all work on using this temp. So we will be running a while loop until unless list1 is not equal to null, and at the same time list2 should also be not equal to null. We will be checking if list1 dot value is lesser than or equal to list2 dot value. If we'll find this, we have to do some work, and same for else part. So if the first condition is true, then we have to append temp dot next equal to list1, and then we have to move list1 one step forward. Same will be done for list2 in else part. If the first condition is not true, that means our list2 is lesser than list1, so we have to do same for list2. Okay, so change it accordingly, and in every step we have to move our temp by one node. Okay, temp is going to be temp dot next. After that we have to check whether all the node has been appended or not. So if we found that list1 is not equal to null, then in this case we have to do temp dot next equal to list1, and same for list2 also. Okay, and then what we have to do, we have to return our result. So as we are using dummy node, we can't return the result, we have to return result dot next. Now run this. So yeah, it is list, it should be list1. Okay, now submit this. So our solution has been accepted, and this is one of the most optimized approach that we can come up with. So I hope you must have learned something from this video. In that case, please make sure to like the video, subscribe to the channel, and don't forget to share this video among your friends. Thank you.